Okay, today we are talking inverses of functions. The basic idea is that in order to have an inverse of a function, you have to switch x and y, and then you have a new ordered pair that is the inverse. Think of it as domain and range are switched. So, find the inverse of each relation, see whether the relation is a function, see whether the inverse is a function. So, all we're doing is we're going to switch for a new x and a new y. And then from here, we want to look at our x values and see if any of them repeat. So because we do have a repeating x value, the inverse is not a function. So if you look at number 2, it's just written a little bit differently with the coordinates. And then you want to look again at the x values. In this case, they do not repeat, so the inverse is a function. So to find the inverse of a function algebraically, it's a little bit different, but very similar. So essentially, if there's an f of x, we replace it with y. We interchange x and y, meaning we do the same exact thing we just did in the last problem. We switch the x and the y value, and then we resolve for y, and then we replace it with the f to negative 1 of x. That means the inverse of the function notation. So if you take a look at example number 3, find the inverse of y is equal to 3x minus 10. There's no f of x, so we don't have to worry about replacing it. We're going to replace it. The x and the y, we're just going to change those around. And then we'll solve for y. So then we'll get y equals x plus 10 over 3. And then we want to exchange the y. Okay, I'm going to erase it. We want to exchange the y for that inverse notation, just to show that that is our inverse function. Try this one on your own, pause the video, and then see how you do. Hopefully you pause the video. First thing you want to do is replace that f of x with a y. And then you want to switch your x and y values. From here, you want to just solve for y. So in this case, we'll multiply by 5 first. We'll subtract 3. And then we'll divide by 2. And again, because this is our inverse, we're going to replace our y with that inverse notation. So there we did it numerically in examples 1 and 2, algebraically in examples 3 and 4. And now we're going to take a look at some graphs. So the kind of cool thing about the graph of the inverse is it's actually a reflection of the line y is equal to x. That's a diagonal line. That's a red diagonal line that you see going through 0, 0. And it creates a mirror image on the opposite side, which is pretty neat. So whenever we're looking at this, my page was moving. Whenever we looked at this, we're going to look to see if our function, if our inverse is a function using something called the horizontal line test. And then we want to see if it is, and the original is a function, then it's considered 1-to-1. So first off, what is the horizontal line test? A horizontal line test is just the inverse of a function test. We do the vertical line test to determine if the original is a function. And we take the original, put a horizontal line through it to determine if the inverse is a function. If they are both functions, then it's considered one-to-one. So if you take a look at example number 5, if I do the vertical line test, the VLT states that it's a function. If I do the HLT, the horizontal line test, it hits more than one. HLT inverse, not a function. Get it? Try example 6. See if you can do example 6 on your own. You might want to pause the video. If you come back, let's take a look here. If we do the VLT, okay, at any point here, we only pass one time through. So VLT, the original is a function. And then let's look at the HLT. So horizontal line test only goes through once. So HLT means the inverse is a function. So now, because they're both functions, this would be considered one-to-one, meaning that there are no x or y values that will repeat. If for some reason one of them is not a function, then an x value will repeat or a y value will repeat. In this case, because they both are functions, a y and an x value do not repeat, making it what we consider one-to-one. Verifying inverse functions, I'd like you to take a look at the other video that I have for this. It just goes through some of these steps. It's not super terrible, I will say, to verify. And then example number 9, trying the composition in order to verify. I think that's a very nice and doable one. But go ahead and check out that other video. If you have extra time in class, I'm sure that you do, in order to see what those two items are all about.